Welcome to Rational Functions.
Oh, you owe me $10.
Alright, first we're going to find the y-intercept by plugging in 0 for the x's. So as you can see, this is our function here. And we're going to plug in zeros for the x's. So we're going to get 0 squared plus 8 times 0 plus 16 times 0 squared plus 2 times 0 minus 8. And then these guys are going to cancel out, because anything times 0 is just going to cancel out. And you're going to get 16 over negative 8. And that's going to equal negative 2. So you're just going to put negative 2 right over here, because this is the y-intercept. So it's going to be right over there, if you could see. And then after that, we're just going to simplify the function. So I already pre-did it for you. So it's going to be, you're going to cross out x plus 4 over here, and x plus 4 over there. And your new f of x is going to be x plus 4 over x minus 2. So that's the new f of x. Alright. Now we're on to step 2, which is finding the x-intercept. So to find the x-intercept, you're taking your new function f of x, and you're going to take the numerator and set it equal to 0. So we're going to do that. And we're going to subtract, and we're going to get x equals negative 4. And that's going to be our x-intercept. So we already have the y, which is here, and the x is going to be right here. So far on our graph, that's what we have. Next step is the removable discontinuities, which you already did. So this is a simplified function. So the ones we crossed out were x plus 4. So we're just going to take these. We're not going to worry about these, because these are our removable discontinuities. And we're just going to set this equal to 0. And that's going to equal the same thing as our x-intercept. And so those are our removable discontinuities. And also to get the y value of the removable discontinuity, you have to plug negative 4 in for the x values. So as you can see, this is the original function, so we're going to plug this in. Plus 4, negative 4 plus 4. And as you see, the numerator is going to equal 0. And then you're going to plug this in, that's going to equal 0. And then negative 4 minus 2 would equal negative 6. But eventually that would cancel out to equal 0, because anything times 0 is just going to cancel out anyway. So you're not going to have any removable discontinuities. No removable discontinuities. Yeah, you get the point.
Yay.
Step 4 is finding the horizontal asymptote. And for this, you're going to take the limit as x goes to infinity. And this is our new f of x. So at this point, you're going to... hold on for a second.
Why are you filming me?
Alright.
So Adam, what are we gonna do?
Alright, so for the horizontal asymptote, we're just going to get x over x. It's going to equal x over x, because we don't care about any of this, because for limits, you don't need the other value. You just need the top values, which is the x's. And you're going to get x over x, which equals 1. So that's our horizontal asymptote, and we're going to graph it right over here. And that's what an asymptote looks like. And then we should already have the x and the y-intercepts. So this is what it should look like at this point.
Yay.
Step 5. You suck, I hate you.
Keep going.
Step 5 is stating the end behavior, which is we already have. And this part is just the same thing as the horizontal asymptote. So we're stating that in behavior, and it's a positive because it's a positive number. That's what we got for the horizontal asymptote. Step 6 is find the vertical asymptotes. And for this one, you're going to take the denominator and set it equal to 0. And that's eventually going to equal plus 2. So that's going to be the vertical, and this is what we already have. So the vertical would be 1, 2. And you're just going to draw your dotted line over here. And that's the vertical. Then step 7, you're going to find your intermediate behavior. So for this one, you're just going to plug, you're going to take the limit as x goes to 2 to the right side. So 2 to the right side would be the plus. And then you're going to take the limit as 2 goes to the left side, 2 to the negative. And this is of the new function f of x. So after that, sorry, a weird person just grabbed my paper. After you're going to plug in anything that's greater than 2, so like 2.1 per se, for x. So 2.1 plus 4, whatever that is, then 2.1 minus 2. And then eventually you're going to get a positive infinity. And we write positive because you're going to get a positive number out of this problem. And that's going to go up because it's positive. And then on this one, 2 to the negative is, we'll plug in 1.9 plus 4, and then 1.9 minus 2. And then eventually for this one, you're going to get a negative infinity, and that's going to go down. And it's negative because of this right here. And that number is going to make the whole problem negative. And basically for the positive one, the graph is going to look like that, like an up arrow. But it's really actually going to be over here, so never mind. The down one is going to be over here, and just scratch that. The up one is going to be over here. So it's going to look like that, and then with those arrows. And then step 8, you're going to find the points where the graph crosses the horizontal asymptote. So for this one, the horizontal asymptote would be, let me get my notes. I think 1. Yeah, horizontal asymptote would be 1. So, no, never mind. I think it's 2 over 1. No,
I think the horizontal asymptote is 1.
Yeah, never mind, it's 1. So 1 over 1 equals f of x, and that's x plus 4 over x minus 2. And then you're just gonna cross multiply this. X plus 4 equals x minus 2. And then these cross out, and then you're gonna have 4 equals negative 2, which isn't true. And so no points cross the horizontal asymptote, none. So now we're done, and this is your graph. I already did it for you. And you have your x-intercept and your y-intercept, and then your asymptotes, your horizontal and your vertical, and then you have the labeled axes, and then this is the original problem. F of x equals x squared plus 8x plus 16 over x squared plus 2x minus 8. And that's how you do it. See you later.